Introduction to computers. This is Wednesday. This is live editing. So today is actually Wednesday. We reviewed this whole concept of investigation, analysis, design, and then the development. We talked about writing software or buying it, implementing, and then evaluation. Talked about how there's such a large amount of data stored in databases all over nowadays. We have all different levels of people, either in a business or people in general, that need to access that. And so how we access it has to do with management information systems. How do we manage all that information? Okay? It's done with software. You can either buy it or write it. And today we talked about writing it, programming. And even the software you buy must have been written. Software is designed to solve a problem. The problem can be almost anything. Nowadays, anywhere from sharing information, like writing software to develop social media, or writing software so you can use your debit card instead of paying cash, or writing checks, or writing software so you can order concert tickets online, or writing software so you can do money transfers between banks, and I mean, it just goes on and on and on and on. Things we want to do, people write software to do that. Here are the steps. You have some issue, problem, thing you want to solve using technology. You get all the specifications on how it needs to work. You design a solution. This is a huge step, making sure you have the design correct before you actually start writing the code. You can give the same situation. You want to build a house. Why? You need more room. You get all the specifications for the house. You do all the designs before you actually start building. Okay, coding, where you write the code, you literally write the software instructions in a programming language that the computer is going to interpret and do. And then I gave some examples of languages, and there's hundreds. I just gave some examples there. Python, like, is another example that's not listed there. Okay? And then once you get the software written, you test it. You make sure it's all documented really well so somebody else could adjust, change it, or use it. And then there's maintenance. All of us should be aware of updates that we get for like Windows or any software. You'll get an update. It'll tell you it needs to update the software. That's maintenance. They go back. They found there's a problem with the software. They spec it out. They design the fix. Somebody writes the code for it. They test it, make sure it works. They document that they've made the change, and then they send it out to you. Usually it's pushed to your computer, and the changes automatically happen. You don't even have to think about it. Once you write code, there's a few steps that happen there. That code, whatever language is written in, is considered a source code. Okay? So you write it, and you have the source code. In a little bit, we'll talk again what does open source mean compared to proprietary. So you have the actual source. Okay? Then it's going to be compiled into an object code that functions on a particular operating system. So it has to match the operating system. So you would compile it to run on Windows 7, or you would compile it to run on your iPhone, or you would compile it to run on your Droid, or your Android, or you'd compile it to run on your tablet, or you compile it to run on your Apple, or you compile it to run on Linux. Object code, then it's linked, brings in a whole bunch of other things that are already there, and you get executable code. The executable, which will run on a particular operating system. Now, besides compiling, we can also interpret. This happens on the run, and you'll see this with scripts. Like you might know there's a JavaScript that needs to run in your browser. Well, it's going to run some code, but it's going to interpret it. It's going to take the source code and interpret it on the run when you need to use it. And so we can write Perl scripts, we can write lots of different kinds of scripts, PHP, and so forth. But it's got to be interpreted. You got to have the right interpreter in order to make it run on a particular operating system. Okay? So this is why when you get software that's been compiled, executable, it executes on a particular operating system. Alright, and then to finish up, software then can be proprietary, like Microsoft has proprietary software, Adobe, they do all this work, design it, make sure they're maintaining it, and then you pay to license it to use it. Okay? You don't actually buy it, because if you bought it, you might be able to do something called decompile, get to the source code, and then you can figure out how it works. That's illegal, because it's proprietary. They own that, and they let us use it. Okay? Now, there's a whole world of open source. Most people think of it as being free, but really the term relates to the fact that you can go in and see the source code. If you have the wherefore to change in just the source code, you can make it like you want it, and it's not, you don't pay for it. Typically that's free. Usually developed by multiple people to create it, like Linux operating system and all those that fit into that Linux world, like Ubuntu and Fedora and all those things. Alright? Now, one rule there is licensing with open source software is you cannot take it, change and adjust it, and then sell it. You cannot sell it to people, because it's open source. All right. So that is it for today. We have the skills based on databases on Friday.